Hello everyone, welcome to the world of SANGAM Aryabhatta. SANGAM is a great place to find yourself with rich services providing enhanced solutions. This is why we recommend using Aryabhatta. Aryabhatta is capable of providing a vast number of solutions in the world of advanced machine learning. Today we are going to discuss how our product performs image classification in the retail domain and identifies all grocery products from different angles and positions. Hey Aditi, it has been a long time. How are you doing?
I am doing great, John. What about you?
I am great, Aditi. Thanks. Enjoying myself with an exciting journey of AI.
What do you mean?
I have built an exciting AI product which can access any image from multiple domains and identifies its status by analyzing the information. All this happens with just one click.
Really? What is that product you got, John?
It is one and only Aryabhatta.
Oh, Aryabhatta name sounds great, John.
Yes, Aditi, Aryabhatta will help you solve all your problems by intelligently utilizing those captured images and easily identifies any retail product available in the store.
That's cool. How are you going to do that, John?
Aryabhatta can do anything, Aditi. Let me demonstrate to you how Aryabhatta performs an image classification on retail store products. First, let us log in into the SANGAM AI page, and then launch the image classification icon to enter into the product workspace. Our products offer various types of data ingestion methods. One of them is to upload a file through UI and the other is through calling REST API services. By invoking a REST API service we can upload a zip file inside the workspace. In order to do that, first, open the Swagger and select the route location for uploading zip files. Now open the Postman, paste the UI URL link, and paste the service URL to upload a zip file. Now select the zip file by giving input name as file and hit the service. Now go and check in the UI and you can see a project has been created successfully with its given label names and images uploaded under each label. Here we are adding 9 different categories of products which are related to soft drinks, tea powder, water bottles, energy drinks, fruits, which are very important in every retail store. Here we have captured images at different angles and positions by rotating the camera 360 degrees so that our model can predict the items from any angle effectively. Shall we start building the rich classification model, Aditi?
I am waiting for that, John, and you know that.
Here in each label, there have more than at least 400 to 500 images which have been assigned with a respective label name. If you want to build a strong model, make sure you have at least 1,000 to 5,000 images for each label in the project to get satisfactory results.
Why is that so, John?
Because the training process essentially depends upon how many images you are using to build the model. Larger the data, more information will be captured by the model, Aditi. Now start building the model by selecting the build icon, and you can see a pop-up open for building the model showing the parameters.
Hey John, can you briefly explain the model parameters?
Sure, Aditi. Here Epoch explains the number of cycles a model runs for training the model using labeled images. Whereas the train batch size is the number of sample images you are providing to the model for each epoch, and finally validation batch size is the sample images you provide for validating the model. Here epoch is taken as 30, train batch size as 100 and validate batch size as 30. Now start building the model by selecting the build icon shown below. You can see the accuracies obtained for train sample and validation samples as 93% and 94%. Every time a model is built, model files will be generated and they will be used further for predicting the images.
Why do we need to generate this model files, John?
Because model files generated after training captures all the information extracted pixel by pixel from the input images provided and stores it inside the model files. So, it has the potential to identify the right retail item for any given test image.
That's interesting.
Yes. Now let us start predicting the model using the browse option shown. Let us upload a test image of a Coca-Cola soft drink bottle and let us see what our model thinks about it. Look, The image has been successfully predicted. The item is the Coca-Cola with an accuracy of 70%. Now let us predict with another test image, which is a product of fountain pens named as Pelican. Let us see what it predicts. Look, it has predicted successfully as Pelican with an accuracy of 86%.
Wow, great John. I was not really expecting that. I have started feeling like my job is going to get easier soon.
Yes, Aditi, I bet it would for sure. Now let us predict test images using the image URL. Here we have given the URL for mineral water bottle named as Adelzener. And look, it has successfully predicted with an accuracy of 88%.
Can you predict for one more item, John?
Sure, Aditi. Let us a test image for tea products as Kamilene tea, and look, it has successfully predicted with an accuracy of 100%. Are you satisfied, Aditi?
Yes, John. I find it awesome the way your model predicting every retail item correctly.
In order to deploy the model, select Deploy option. A pop-up rises. Now we can deploy the model in the cloud services such as OpenShift, Amazon services, Azure, and perform predictions in the cloud environment as we have developed user interface page in the cloud. Here we need to provide the email address, model file name you want to deploy, and select the target deployment option to where you want to deploy. Here we have selected OpenShift and deployed the model. Check your mailbox and you can see that the Retail Images project has been successfully deployed, and you can access these models using the URLs shown. Select the first URL and it takes you the page where you can use the UI in a cloud environment. Select the UI icon and start predicting the test images here. Now select the Swagger for finding the route location for the prediction service. Let us use this service manually to predict the test images from the Postman. In order to do that, let's first copy the second URL from the mailbox, and paste it in the Postman, and then copy the route location from Swagger as shown, and paste the location in the Postman beside the URL. Now provide the input structure in JSON format as shown, giving the image URL of the mineral water bottle. You can see the image has been predicted as Adelzener with an accuracy of 87.5%.
That looks amazing, John.
Thanks, Aditi. This completes the building of the image classification model, making your life easier, sharing the load of your work, and analyze the information provided in the data.
Yes, John. I might need to have a professional meeting with you soon.
Sure thing, Aditi. This is how we can perform predictive modeling process using our product, the one and only Aryabhatta. Stay tuned for the new exciting applications we are going to build. Sounds exciting, right? Until then, keep predicting. That's all for this video. For any queries, please reach us at vj.reddy@sangam.ai.